Hello, class, and welcome to this lesson. Today, we are looking at summary statistics, and our focus will be on measures of central tendency. My name is Eunice Frimpong, and I'll take you through. Let's look at this activity. Two classes obtained the following marks. Class A had 5 students scoring 50 points each. Class B had its 5 students scoring 20, 40, 50, 60, and 80. So each student had a different score. Now, discuss the following questions. Which class appears to have performed better? What's the typical mark in each class? And are the marks equally spread out? So by the end of the lesson, students should be able to explain the meaning of summary statistics, distinguish between measures of central tendency, and then measures of spread. Also, you should be able to calculate the mean of grouped and ungrouped data. You should be able to calculate the median of grouped and ungrouped data, calculate the mode of grouped and ungrouped data, interpret measures of central tendency in context, and identify common errors when calculating summary statistics. What are summary statistics? These are numerical values that are used to describe and summarize the main features or the main characteristics of any data set. So previously we looked at representing data sets with tables and graphs, like the histogram, the frequency table, and other kinds of graphs. Now, summary statistics allows you to still represent data in a certain form. However, with this, you are describing and summarizing the main features of your data set. So there are two main types. We have the measures of central tendency, and then we have the measures of spread or variation. Under measures of center, we can talk about the mean, the median, and the mode. And under measures of spread, we have the range, the variance, and standard deviation. Now, here are two important definitions to consider. Statistic versus parameter. Now, this statistic, take note, is without an S at the end. So we define statistic as a statistic is a numerical characteristic calculated from a sample, whereas parameter is a numerical characteristic calculated from an entire population. So the difference between statistic and parameter are the two words sample and population. A sample is a representative portion of an entire population. So the entire population is a whole group, say all Ghanaians. I can pick a sample of Ghanaians and define them as Ghanaians who live in the Greater Accra region. Therefore, all Ghanaians are the entire population. Ghanaians who live in the Greater Accra region becomes a sample because it is a representative group of the entire population. Ghanaians who live in Greater Accra region are Ghanaians too, but they are not all Ghanaians. Other Ghanaians live in other regions. Let's take an example here. So a numerical characteristic we may want to calculate may be the average mark. The average mark. So you look at the average mark of 50 selected students we will refer to that as a statistic because you are considering the average mark of 50 selected students. So it represents a portion of the entire group. But when you look at the average mark of all students in the university, then you are referring, this average mark is called a parameter because it represents the entire university body. The first summary statistic of central tendency that we want to look at is the mean. The mean is the sum of all observations divided by the number of observations. So there are two important phrases here. This says sum of all observations and then number of all observations. So that is your focus. We have here the sum of all observations, and then we have here the number of all observations. So these are the two. So the sum of all observations, in calculating the mean, the sum of all observations will be in the numerator, and then the number of observations will be in the denominator. If you look at this formula, you can see that in the numerator, we have the summation symbol. This here, E sort of thing you see, we call it the summation symbol in math. So this signifies summation of xi. Xi represent the data point or your observation. So you can see that you're using X bar to represent the mean. Whenever you see X bar, it means the mean or the sample mean. Now, X bar is equal to X1 plus X2 plus all the way to the last observation, Xn. We don't know it, so we're using N to represent the last observation. All divided by N, and N represents the number of data points. So if the observations are ages of 5 students, we have someone is 20, 21, 24, 30, and 35. These are the ages of 5 students. Then we say that to find the mean, first of all, you have to simply sum these 5 numbers divided by the number of them. How many are they? 1, 2, 3, 4, 5. So N is equal to 5. So you put your 5 here like that. You sum everything here and you write a total number there. So we are defining X bar here as the sample mean. Xi is the ith observation and N is the number of observations. The mean may be interpreted as the value each observation would have if the total were shared equally. So you may have some observations that will have different values, but just in case we're sharing these observations equally, let's say that you have some five staff of university staff, okay? So you have staff A, staff B, staff C. Let me make it just three. Staff A earns 5,000 cedis, staff B earns 2,000 cedis, and then C earns 4,500 cedis. Now there are three staff here with different salaries or wages. How do you know? When we talk about average or the mean, we are saying that just in case we wanted each of these to have the same amount, how can we go about it? We can just sum the individual salaries and divide it by 3 because there are 3 of them. So this gives us 11,500 divided by 3. And whatever you get, so this will give us 11,500 divided by 3. That is 3,833.3. So each of them will have 3,833 if we want to share or give them the same salaries. Yeah, so that's a concept of average. Suppose 4 students have the following number of books, 2, 4, 6, 8. The total number of books is 2 plus 4 plus 6 plus 8 equals 20. If the 20 books are shared equally among the 4 students, X bar is equal to 20 divided by 4, which is the number of students, and that gives us 5. So the average number of books is 5. Each student will have 5 books. How do you go about calculating the mean? I have demonstrated this, so let's read through the process. Add all the observations, count the number of observations, divide the total number of observations by divide the total by the number of observations. Then you state the answer using the appropriate unit. Make sure that you do not commit the error of dividing by the largest observations. You divide by the number of observations. So example, the following data represent the number of days off per year for 9 individuals. Find the mean number of days off. Let's sum all the observations. The total of these gives us 276. How many observations are here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the n is equal to 9. Therefore, to know the mean, you simply use the formula x bar equals summation of xi over n. And we had a summation of xi to be 276. So we have here 276 divided by n, which is 9. And that is giving us 30.666. So approximately, each worker is enjoying 30.7 off days in the year on the average. Now, here's an example. The numbers of assignments completed by 8 students are given below. 1, 2, 3, 4, 5, 6, 7, 8. So it's already established that n is equal to 8. Now we need to find the summation of the x's. So we're going to say 6 plus 8 plus 5 plus 10 plus 7 plus 9 plus 4 plus 7. So that should give us 6 plus 8 plus 15 plus so we have 6 plus 8 plus 15 plus 7 plus 9 plus 4 plus 7, giving us 56. So 56. Therefore, the mean is equal to summation of xi all over n, which is 56 over 8. And that should give us 7. Therefore, on the average, these students completed 7 assignments. Now, how do you find the mean in the case where the data you have are not simple data points like we've seen previously, like simple data points like this? What if it is a grouped data? What do you do? For group data, the individual observations are not known. We don't know the individual observations because all we were given is the table, the grouped table. So we use the class midpoints to represent the value of each class. How do you find the class midpoint? For each class, you take the lower class boundary and the upper class boundary. You sum and divide by 2. You can also use the lower class limit and the upper class limit. Sum and divide by 2. The estimated mean is x bar equals the summation of f of xm all over summation of f, where f is the class frequency. And xm here is the class midpoint. So what are the steps? First of all, find your midpoints of each class. Multiply each midpoint by its corresponding frequency. Now find the total frequency and the total f times x, and then you apply this formula. So here is an example. We have this table. It's a group table. We have the class boundaries provided and the frequencies. You want to estimate the mean number of miles run. So to do that, you take your table and then you create a new column that will have your midpoints. To know our midpoints, we just take each, so for each boundary, this one we have 5.5 plus 10.5 and then divided by 2 to give us 8. And we have that here. Second one, we have 10.5 plus 15.5. which gives us 26 divided by 2, and that's 13. And that's what we have here. So you apply it for all the remaining class boundaries. So after you've filled in all your class midpoints, the next step is to multiply each frequency by the corresponding midpoints. So in the first instance, we have 1 times 8 giving us 8. Second row, 2 times 13, 26. Third row, 3 times 18, 54. You do that for all the other rows. When you are done, you sum all your frequencies to give you 20. Sum all your f times x's to give you 490. And according to the formula, so we have summation of f equals 20, summation of fxm equals 490. So we just pick the formula, which is x bar equals summation of fx over summation of f. We had summation of fx to be 490 and summation of f to be 20. So then we have 490 divided by 20, and that gives us 24.5. So on the average, the runners covered approximately 24.5 miles during the week. Here is another example. Calculate the estimated mean for the following distribution. I have my class intervals and my frequencies. I'm going to extend this. First of all, I want to write the formula. So I know that my x bar equals summation of f times x all over summation of f. So I know that I need my x values, the class midpoints, which you can say xm. For the first one, 0 plus 10, I mentioned instead of class boundaries, you can also use the class intervals. So 0 plus 10 divided by 2 is 5. So we have here as 5. 10 plus 20 is 30. 30 divided by 2 is 15. 20 plus 30 is 50. 50 divided by 2 is 25. 30 plus 40 is 70. Divided by 2 is 35. 40 plus 50 is 90. Divided by 2 is 45. Now we're going to look at the frequency times the x's. So for the first row, we have 3 times 5. This times 5. That's 15. 15 times 5 is 75. 25 times 7 is 175. 35 times 4 is 140. Then 1 times 45 is 45. According to the formula, I need the summation of the frequencies. So I have 3 plus 5 plus 7 plus 4 plus 1. So the total gives us here as 20. Then we also sum the f of x's. That is this particular column. So 15 plus 75 plus 175 plus 140 plus 45, and that gives us 450. So back to the formula. Summation of fx is 450 all over 20. So here we have 22.5. Yeah, as the average or the mean value for this particular table. So this is our final answer. The next section is to work on the median. So median is the second measure of central tendency. Now, the median is the middle value of an ordered data set. So if the data set contains an even number of observations, then the median is the mean of the two middle observations. Here is a key property. The median divides an ordered data set. Take note of the word ordered. Your data set must be in order. The median divides an ordered data set into two approximately equal parts. So at least 50% of the observations are less than or equal to the median, and at least 50% of the observations are greater than or equal to the median. Always arrange your data in order before you find the median. What are the steps? First of all, arrange the observations in order. Count the number of observations. If n is odd, select the single middle observation. If n is even, find the mean of the two middle observations. So for an odd number of observations, the median position will be n plus 1 divided by 2. Here's an example. Find the median of 713, 300, 618, 595. I mean, these figures, okay? First of all, let's arrange the observations in order. We'll do ascending order. So after arranging in order, we have this. Now note there are 7 observations. So once they are odd, you can find the median by simply taking the number of observations. We'll use the formula. If odd, if the data points are odd, you use n plus 1 divided by 2. Here n is 7, so 7 plus 1 divided by 2, which is 8 divided by 2, giving us 4. So your median will be the 4th position. So we start counting. First, second, third, fourth. So this then becomes our median. Now find the median of these sets of numbers. We have 1, 2, 3, 4, 5, 6. Now these are even numbers. So to find the median, find the two numbers in the middle, which is in this case 3 and 3, and then find the average of these two. So you add 3 to 3 and divide by 2, and that still gives us 3. Therefore, the median we say is 3. Here are some examples again. Determine the median of each data set. Let's look at data set 1. If I arrange this in order, the first number is 2, 4, 6, 7, and then 9. There are 5 of them. 1, 2, 3, 4, 5, 6. Right. So this is an odd set. So I'm going to apply n plus 1 over 2. Here there are 5 numbers. So 5 plus 1 over 2, giving us 3. 6 divided by 2 is 3. So I'm looking for the third position. So I start counting 1, first, second, third. Therefore, 6 is my median. Let's look at number 2. 1, 2, 3, 4, 5, 6. These are even numbers. So first of all, again, let's arrange them in order. We have 3, 5, and then we have 8, 9, and then we have 10, 12. The two numbers in the middle are 8 and 9. So I'm going to take 8 plus 9 divided by 2. That gives me 17 divided by 2. And that's 8.5. Therefore, the estimated median number is 8.5. What about the case of having a grouped data? How do you estimate the median when you are not giving individual data points, but you are given a table which has grouped data points? There is a way. and you have to apply a formula. This is the formula. Median is equal to L plus everything you have here. We're going to define each of the variables in this formula. L is the lower boundary of the median class. N is the total frequency. CF is the cumulative frequency before the median class. FM is the frequency of the median class. And W is a class width. So what are the steps in finding the median class? First, remember, consider everything, the definitions here. It says L is something, something of median class. CF is this of median class. FM is this of median class. So we must find the median class. This is a formula once again. To find the median class, find the total frequency, which is your N, divided by 2, and then locate the first cumulative frequency that is equal to or greater than the answer you get for N over 2. The corresponding class is the median class in that case. So the median class is not necessarily the class with the highest frequency. It's a class that contains the N over 2 observation. The table shows the number of hours students studied in 1 week. Calculate the estimated median study time. So we've seen the formula and all the processes. Now you want to demonstrate it in an example. We have here the table given, class boundaries, frequency, and cumulative frequency. So the table is once again here. You know that the first step is to find the median class. So to find the median class, find the total frequency. In this case, is 20 divided by 2. 20 divided by 2 is 10. So the first cumulative frequency that is equal to or greater than 10 becomes the corresponding median class becomes the corresponding class becomes a median class. In this case, when we divided by N divided by 2, which is 20 divided by 2, we had 10. So let's look at which cumulative frequency is the first to be either equal to or greater than 10. It's 15. 15 is greater than 10 and is the first number to be greater than 10. So you just pick your pencil or whatever, you do an eyeballing. You move 15 all the way to the class, the corresponding class. So then this becomes our median class because it's a class that corresponds to 15. Therefore, our median class is 10.5 to 15.5. So we have our median class highlighted or boldened. This is the formula for the median. So from the median class, we know that our L is supposed to be the lower class boundary of the median class. That is 10.5. Now CF is the cumulative frequencies of all the classes before the median class. So the cumulative frequency just before the median class is 8. So we have 8 here. Then FM is the frequency of the median class. The median class is here. Its frequency is 7. So we have 7 here. The class width is the difference between the upper class boundary and the lower class boundary of any of them. So I'm going to take the first one. You can use any of them. I'll take the first one. The upper class boundary is 5.5 minus the lower class boundary of 0.5, and that's 5. So we say the class width is 5. And then we have N. N is giving us 20. So this portion of the formula, N over 2, we found it here as 10. So when you have done all of this, what you do is just fix in the realizations of each of the variables. The median is equal to 10.5. I mean, whatever you see here, according to the formula, you fix everything in, you simplify to get 11.9. Therefore, the median is approximately 11.93 hours. So what does this mean? It means that approximately half of the students studied for less than 11.93 hours, and half of the students studied for more than 11.93 hours. Now, the grouped median is an estimate because the exact observations within each class are not available. So what we have gotten here is just an estimate because we don't have the precise data points. Here is another example. Find the estimated median class for the following distribution. So we work it together. First of all, you must find the median class. We are going to find the total frequency. 4 plus 6 is 10, plus 9 is 19, plus 7 is 26, plus 4 is 30. So total frequency is 30. Now 30 n divided by 2 is 30 divided by 2, which is 15. So but before we do this, so it's 15, we just take note of that and keep it. I need to create another column for the cumulative frequency. So let's start 4. 4 plus 6 is 10. 10 plus 9 is 19. 19 plus 7 is 26. 26 plus 4 is 30. So the first cumulative frequency that is equal to or greater than 15 becomes what we will decide as our median class. From the look of this, 19 is the first number that is greater than 15. 10 is lesser, so we can't consider that. So the corresponding class becomes our median class. Okay, so that's our median class. Moving on, we now have to find the various variables in the formula. So what is L? L is the lower class boundary of the median class. In this case, it's 10.5. N is 30, total frequency. CF is the cumulative frequency of the class just before the median class, which is here. The class just before the median class is this. Its cumulative frequency is 10. FM is the frequency of the median class, which is 9. It's here. Then W is the class width. So I take any of the classes. I'll take the first one and find their difference. 5.5 minus 0.5. So the W is 5. I'm done. The rest is just fix everything into the formula. So here I have L is 10.5 plus N is 30 divided by 2 minus CF is 10 all over FM is 9 times W, which is 5. So we keep on solving. 10.5 plus 30 over 2 is 15. 15 minus 10 is 5. So we have here 5 over 9 times 5. So giving us 10.5 plus 25 over 9. And in total, we have 13.277 recurring. Therefore, the approximate value of the median is 13.277 recurring. And you are done with your solution. So these are the formulas for mean ungrouped, mean grouped, and median grouped. So here are some questions to check your understanding so far. What is the difference between a statistic and a parameter? So yeah, we'll go through these questions together. The next measure of central tendency we are looking at is the mode. The mode is the value that occurs most frequently in a data set. So, for example, look at this data set. We have 2, 4, 4, 5, and 7. The value 4 occurs 2 times. Every other value occurs once. So we say the mode is 4. The mode is determined by the frequency, not by the size or position of any value. So why is the mode useful? Numerically, the mode can identify the most common exam score, the most common shoe size, the most common household size, the most frequent waiting time. Categorically, it could look at the most preferred mobile network, the most preferred or the most common blood group, the most popular program, or the most frequently used browser. So unlike the mean and the median, the mode is just can be used also with the categorical data. Mhm. Now, there are types of mode. A data set may have one or several modes, or may have no mode. We say that it's unimodal if it has only one value, which has the highest frequency. It's bimodal if there are exactly two values that share the highest frequency. It is multimodal if there are more than two values that share the highest frequency. And there is no mode if no value occurs more frequently than the others. If a data set has no mode, a data set has no mode when all observations occur with the same frequency. It is not that every observation must occur once. No, it is that all observations occur with the same frequency. Then there is no mode. So classify each data set as unimodal, bimodal, multimodal, or having no mode. Let's do it together. In this case, we have 2, 3, 3, 4, 5. 3 occurs twice, and 3 is the only number that occurs twice. All the others occur once. So then the mode here is, so let me just write here mode and make this like a table. Okay. So the mode here is 3. And what type of mode is this? This is a uni mode because it has just one mode. Now look at this number. 1 occurs 2 times. 2 occurs 2 times also. 3 occurs once, 4 occurs once. So the mode here are 2. There's 1 and then there's 2. This is a bimodal data set. Let's look at this. We have 4, 4, 5, 5, 6, 6, and 7. So 3 numbers each occur 2 times. So all 3 of them are the mode. So we have 4, we have 5, and we have 6. So this is a multi mode. Then we have 2, 3, 4, 5, 6. All the numbers occur just once. None of them occurs more than the others. So here we have the mode is none, nothing. So this is a no mode. So here is how to go about classifying each of these data sets. Mhm. Example, find the mode of the following observations. We are here 98, 100, 102, 102, 102, 104, 105, 107, 109, 110. Let's check them out. I've written out all the data points. We have 98 occurring once, 100 occurring once, 102 occurring three times. We have 1, 2, 3. 104 once, 105 once, 107 1, 109 1, 110 1. Therefore, the value 102 is occurring more frequently than any other value. So the mode is 102, and it is a unimodal data set because there's only one mode in it. Another example, find the mode of this data set. So you count the relevant frequencies. Now, frequency of 104 is 5. Frequency of 109 is 7. Therefore, 7 will be our mode. No, 109 will be our mode because it has the highest frequency. So the mode is 109. And this is a unimodal data set because there's only one mode in there. Here is another example. If you look at this data set, 104 occurs 5 times. 109 occurs 5 times. The rest occur just once. Therefore, because 104 and 109 are sharing the highest frequency, we say that they both are the mode of the data set. So this is a bimodal data set with the mode of 104 and 109. Now, here's another example you can try your hands on. Find what the mode and whether it's a unimodal, bimodal, multimodal, or it has no mode. So for group data, the class with the highest frequency is called the modal class. For group data, the class with the highest frequency is called the modal class. Yeah. So you can find the modal class by just looking at the frequency. But to find the modal estimate, you will have to use a formula. So if some group data have these as their frequencies, the frequency of the first class is 5, 9, 14, 10, and 6, like that. Then we'll say that 14 is the highest frequency. So the class that corresponds to 14 is the modal class. However, if we want to find an estimate of an estimate of the mode, we have to use this formula. So as is done in the case of the median, we will have to define these variables. They are well defined here. L is the lower boundary of the modal class. Fm is the frequency of the modal class. F before is the frequency of the class before the modal class. F after is the frequency of the class after the modal class. And W is the class width. Now, D1 is D1 is Fm minus F before, which we define here. And D2 is Fm minus F after. So here are the steps. First of all, you must know what your modal class is by finding the highest frequency. Then you find the lower boundary of the modal class, the class width, then calculate D1 and D2, fix it all into the formula, and then you have the mode. The table shows the distribution of marks obtained by some students. Just by looking at this table, you can know the modal class because the highest frequency here is 14. So the class that corresponds to 14 is our modal class, and that's 50.5 to 60.5, and we have that written here. So we found our modal class, which is here. Yeah, this is our modal class. So then we can know L. L is the lower boundary of the modal class. So L is 50.5 written here. W is the class width. So I can take any of the classes. I can use the modal class and then I'll say 60.5 minus 50.5 equals 10. So the class width is 10. Now we must know the frequency of the modal class, which is 14. Frequency of the class before it, which is this one, the frequency is 9. And then the class after it is this, the frequency is 10. So F after is 10. We know that D1 is Fm minus F before, so we have 14 minus 9 equals 5. D2 is Fm minus F after, which is equal to 14 minus 10 equals 4. So now that I have my L, W, D1, and D2, I just fix everything into the formula, and then I go ahead and calculate to get my final answer as 56.0556. What does this estimated mode mean? We have 56.06. It suggests that the scores around 56.06 were the most common within the distribution. So we found our modal class to be 50.5 to 60.5, and we found our estimated mode to be 56.06. If you have asked to find modal class, if you are asked to find an estimated mode and you find the modal class, you have deviated. The modal class is different from the estimated mode. So here's another example. Oh God. We have the class boundaries given and some frequencies. You want to estimate the mode. First of all, straight away, I can see my modal class because I'll look for the highest frequency, which is 13. Therefore, my modal class is 29.5 to 39.5. I'll just tick it. Yeah. Okay. So then I can know what L is. L is the lower class boundary of the modal class, which is 29.5. W is the class width. So using the modal class or any other class, 39.5 minus 29.5 is 10. So the class width is 10. Now we can find Fm, which is the frequency of the modal class, 13. F before, the frequency of the class before the modal class, which is 8. Then F after, frequency of the class after the modal class, which is 10. So we have D1 being equal to Fm minus F before, which is 8. And then D2 is Fm minus F after, which is 10. So putting it back into the formula, we have L, which is 29.5, plus D1, which is 8, over 8, plus D2, which is 10, all times W, which is 10. So we can put all this into a calculator. And then we are getting 29.5 plus 4 over 9 times 10. And that should give us 33.944. Okay. Okay, so this is a modal estimate. 33.944. So here are some examples. You have a table, estimate the mean, the median, and the mode. And here are the solutions. So you can try it and then check the solutions to see if you're on track. We have the estimated mean, the estimated median, and the estimated mode. For this particular example, the mean is found to be 68.1. The median is 67.5 and the mode is 66.5. We see that the mean is bigger than the median and the median is bigger than the mode. So the question is, why are the three values not equal? And what might their order suggest about the shape of the data? And which values best represent the typical score? So here are each of the measures and then their main strengths and their main limitations. There's mean, median, and mode. For mean, the main strength is that it uses every observation in its calculation. And the main limitation is that it is strongly affected by extreme values. For median is resistant to extreme values, but it does not use the precise size of every observation. Mode can be used for categorical data, but it may not exist or may not be unique. So the most appropriate measure depends on the type and the distribution of the data. I did mention here that the mean is strongly affected by extreme value. So let's look at the whole extreme value concept. Consider this data set. We have 10, 12, 13, 14, and 16. Its mean is 13 because if you sum everything, you get 65 divided by 5, that gives you 13. And its median is 13. Now replace 16 with 100. So now we have the data points given us. So the first one, this was the data point. This time around, if you place the last number instead of 16, we've made 100. 16 has been replaced with 100. Now the new mean, everything else stay the same. The new mean is now, if you sum everything here, is 149 over 5, which is 29.8. So you notice that when we changed the last number from 16 to 100, the mean changed. The mean moved from 13 to 29.8, but the median remained the same. The median in the first instance was 13. When 16 was changed to 100, the median is still 13. So you realize that the median was not affected by this change of value to 100, which is an extreme value. Because if this represents ages of some people, these are all children, 10 years, 12 years, 13 years, 14 years. This is a grandparent, 100. So that's an extreme value because it's very, very different from the rest of the values. So you see that the mean was heavily impacted by the extreme value, but the median was not changed, was not bothered at all by the extreme value. Okay. So here's another example. With this example, you can find the mean, the median, and the mode. Here are some common errors you must bear in mind when you are working with mean, median, and mode. And finally, this is the formula once again of the mode. Okay. All right. Thank you for joining the class, and I'll see you in the next lesson.